Howdy. Today we are going to be working on section 7.5, which is working with properties of logs. So yesterday at the end of our work, we did a little bit of review that we just covered, which is the review of our rules of exponents. So again, I'll remind you, when we have common basis and we're multiplying, the rule is to add the exponents and keep the base the same. With division of the exponents of same basis, our rule is to keep the base the same and subtract the exponents. Easy peasy. The other rule I'll remind you of is when we are raising exponents, our rule is to multiply and keep the base the same. So again, nothing new there. These are the same kind of characteristics you guys have been seeing. In fact, you guys did it yesterday with fractions, and it was almost uglier than what we're actually going to deal with today. So I do want to remind you guys that logs are inverses of exponents, and exponents are inverses of logs. That's really been the theme of this whole chapter, and you guys should be very familiar with what happens with domain and ranges, with our asymptotes, where I have graphs of exponents and graphs of logs. Today, no graphing, so I know some of you guys are going to cheer about that, and we're really just going to focus on the ideas of what properties of logs do. Hint, hint. They're going to do the inverse of what the properties of exponents do. So if you're okay with the properties of these exponents, then you're going to be fine with today's properties of logs. Almost as if they're supposed to go hand in hand. All right. Before we get moving on to that stuff, I want to introduce you to a thing that's called change of base formula. Change of base formula enables us, and I talked to you guys earlier about this with your calculators. With your calculator, there's only two log buttons. There is the common log, and there is the natural log. And a reminder that the natural log is a log base e, and the common log is a log base 10. However, many of the things that we've manipulated in class, they do not have a base 10, and they don't have a base e. They have a base of 3, a base of 4, a base of 1/2. But we have the change of base formula, and that allows us to go ahead and calculate any log we want, whether it be base 3, base 4, by changing it into a common log or a natural log. And change of base is very straightforward. We just split it into two fractions and give it a new log. So log base c of a will change to log of a divided by the log of c. And we've done our change of base formula. The other thing you can do is you can make it the natural log of a divided by the natural log of c. And I just dropped my pen. Okay, change of base formula works pretty straightforward. I'm just going to show you a quick example, and you will do a checkpoint on it. There will be a lot of checkpoints today, so not just 3 checkpoints. I think there's going to be like 4 or 5, so save some room on your paper for 4 or 5 checkpoints. They'll be coming pretty quick, though. I think today's lecture is only going to be about 20 minutes. So, example number 1, use change of base formula to evaluate that logarithm. And it says round your answer to 3 decimal places. Evaluate log base 6 of 11. When you're looking at this, first thing you should realize is that, no, this is not a natural log. No, this is not a common log. So what I can do is apply the change of base formula. That's the thing I just told you about. And I'll rewrite it. If I can spell rewrite, I'll rewrite it into the log of 11 divided by the log of 6. I could also rewrite it if I wanted to. This is an either-or situation. I could rewrite it as the natural log of 11 over the natural log of 6. At that point, I can crunch either of these in my calc. So, evaluate and then round it to 3 decimal places. Use your calculator. And for me, that's going to be the log of 11 divided by, I believe it was the log of 6. Yeah. The log of 6. Make sure you're closing both of those with parentheses. If you do have a TI, it works just in the exact same format. Hit enter. It's a pretty straightforward thing. and routed to 3 decimal places, so this will be 1.338. So 1.338, that's all we have to do there. Change of base works, as I told you, you could also do it with the natural log. I will show you the natural log real quick. Natural log of 11 divided by the natural log of 6. And I am shocked to see that those two numbers are exactly the same. Oh me, oh my, I am beside myself in awe. All right, after this, you guys got a checkpoint. Do that one real quick. Use your calculator. Pause the video. Change of base should be really straightforward. Should take you maybe 15 seconds to do that, and we're moving on. Pause the video, and then move on. Okay, hopefully you're back from pausing that video. We're going on to the next example. Product property with logs. Log base b of m times n. Here's how this product property is going to work. Remember, exponents are inverses of logs. Logs are inverses of exponents. So, when we had exponents of a common base and we multiplied them, we added the exponents and kept the base the same. Now, we have multiplication within our exponent up here. That's a log base b of m times n. So we have m times n within that expression. So that means multiplication for logs, when we it's called expanding, we will change it to addition. Again, this will now say log base b of m plus log base b of n. Multiplication becomes addition. Okay? Now we can also, that's usually when they say expand an expression, that's what it's asking us to do. Sometimes you're going to see make it collapse or shrink it, something like that. So we could also take this log base b of m plus log base b of n, and we can write it as 1. Log base b. Once again, addition means multiplication, so that's m times n. Notice that the rule works both ways. And this is usually called condense. Okay, remember, multiplication means addition. Got it. Here's how it looks. Evaluate the log base 5 of 36. Now I do know you can use change of base on this. However, on your exam, when you're not allowed to use a calculator, I will ask you to do a problem like this. Log base 5 of 36, and I will tell you some other things. Log base 5 of 4 and log base 5 of 9. Mr. Wood, that doesn't help me very much. Oh, it does. Because I can rewrite log base 5 of 36. Instead of writing the number 36, I'm going to write it as 9 times 4. Because 9 times 4 is 36. Notice we've done a lot of rewriting in this chapter. And the reason I'm going to rewrite it as 9 times 4 is, well, that's what they gave me over here. Since I now have multiplication, I can split this as to log base 5 of 9 plus log base 5 of 4. And, oh me, oh my, I'm shocked to see that they gave me log base 5 of 9, which is 1.365, plus the log of 4, which is 0.861. That point, again, non-calc means you have to add that up by yourself. Line up the decimals. And the answer is going to be 2.26. Okay? Notice splitting or rewriting 36, this time as multiples, things they gave us. Multiplication of a log means addition. I split it into 2 parts, use what they gave me, and apply it. Pretty straightforward stuff. You could have written that, let's see, I don't know how else we could have done it. Not coming off the top of my head. All right. Next problem, not asking us to do anything except for expand or condense. First problem says log base 2 of x, y, z. Second problem says condense log base 7 of x plus the log base 7 of w. Expand, we have x times y times z here. So that's going to be a log base 2 of x plus log base 2 of y plus log base 2 of z. That's it. You're done expanding that thing. I swear that's all it is. It's really easy. I know. I told you guys logs was easy. Condense log base 7 of x plus log base 7 of w. That's multiplication. It's addition, so that means multiplication. I will keep the base the same and multiply x times w. Log base 7 of x times w is the exact same thing as log base 7 of x plus log base 7 of w. Multiplication means addition in the problems. All right. Now you guys got a checkpoint on this? Oh, nope, I don't have a checkpoint for you. I'm going to advance you guys into dividing. If our rules for multiplication was addition, then the next logical step, I think, should be with division, we should subtract. And that's exactly what happens. When we have division, we subtract. First two problems. Log base 4 of x over y, then log base 8 of 4 minus log base 8 of 12. Top one, log base 4 of x divided by y. Yeah, this is division, so we'll make it subtraction. Log base 4 of x minus log base 4 of y. Done. Condense. Log base 8 of 4 minus log base 8 of 12. Subtraction means division. That's going to be log base 8. Hold on, there's a bell.
Ali Shalai.
All right, that's going to be, subtraction is going to be division here. So I'm going to keep the base the same. And I'm going to make that 4 divided by 12. I'll reduce that fraction. So this is going to be log base 8 of 8 of 1 over 3. That's it. That's all we got on that problem. Checkpoint for you guys. Pause the video, do these two problems. You're looking at log base 9 of 7 over x. And then I need you to condense log base 2 of 14 plus log base 2 of m. Again, you should be applying multiplication and division properties on these. Just expand and condense. Make sure you know how to do it. Pause the video. Unpause it when you're ready to move on. Okay, should be moving on here. Power properties. Log base b of m raised to the n. Our rule before, when we raised exponents, so we've hit multiplication, we've hit division. Our rule before, when I was raising to an exponent, was to multiply the exponents and keep the base the same. The rule is very similar here. An exponent, or raising to an exponent, is going to mean multiplication. What's actually happening is this will simplify, or another way to write it as n times the log base b of m. The n will become a multiplier. Okay? You're raising to an exponent, that means multiplication. So, apply it. Log base 3 of x squared, and then condense 5 natural log of x. These are almost like parent functions here. If I'm going to expand this, that means, let's see, I got to get rid of that. So not rid of it, but I'm going to move it. That's going to be 2 log base 3 of x. Again, I'm raising to an exponent, so that means multiplication. 2 times log base 3 of x. Condense. Make it smaller. Right now I have 5 times the natural log of x. 5 times the natural log of x. I'm going to move to the exponent position. That will be the natural log of x to the 5th. Done and done. These rules behave just like your rules of exponents. You guys, same game. These are going to be a little bit trickier, but I have a hunch you guys can do it. Pause the video, and I actually think, hold on, let me switch the slides real quick. Oh, yep, I do have some more examples. So pause the video, go ahead and see what you can do on this. I'll actually break down those problems in just a sec on my next slide. So pause the video, attempt them, and see what you can do. All right. If you struggled with that last checkpoint, again, if you struggled with that last checkpoint, I'm going to do these 2 problems, and after I finish these 2 problems, I want you to go back and work on that checkpoint. Hopefully these 2 problems will help you get through the problem if you had an issue with it. First one, expanding. I'm looking at log of 7y cubed divided by 4x squared. Again, the log of 7y cubed divided by 4x squared. First thing I recognize is that I have division here. So I'm going to split that into 2 parts. That's going to be the log of 7y cubed minus the log of 4x squared. Again, that takes care of my division. Now I'm going to look at the log of 7y cubed. I realize that the log of 7y cubed, that's actually saying 7 times y cubed. So I can take this expression and I can expand that more because multiplication means addition. So log of 7 times, plus the log of y cubed. That's log of 7y cubed. I also am subtracting, and I'm going to put this in parentheses now to remind you that I'm working with the denominator over here. That was what was on the bottom before. I'm going to move this a little bit lower. Okay? I'm going to subtract the denominator. That's already taken care of. That was a division before. But now in the denominator I had 4x squared. That's saying 4 times x squared. So really I have a log of 4 plus the log of x squared. Again, this is multiplication. Multiplication means addition. And again, there's my multiplication. Hopefully you're looking at this problem and saying, Mr. Wood, I can take this a little bit farther in my expansion. I can't do anything with the log of 7. I can make that exponent multiplication. Plus 3 times the log of y. Again, multiplication from raising to an exponent. Your choice, you can distribute that negative through, or you can leave that whole expression in parentheses. I tend to just leave it all in parentheses. That's going to be the log of 4. I can't change that. However, I can also change the exponent here, and that's going to be 2 log of x. There we go. And if you'd like, you can keep parentheses around that also. There's your expansion. Make sure you see how all of that fits together. Realize that I can take this bottom and go all the way back up and condense it to my original equation. This expression will condense back to this expression. But it asks you to expand it. Now, oops, don't want to do that. Next problem, take something big, make it small. That's condensing. Natural log of 3 plus 2 natural log of x minus natural log of y. That's a natural log of 3 plus. Hopefully you realize that's 2 times the natural log of x. Mr. Wood, I recognize. That's an exponent. So that's going to be the natural log of x squared minus the natural log of y. Next thing I noticed, this is addition. That means multiplication. That's going to be the natural log of 3x squared. Addition means multiplication minus the natural log of y. Mr. Wood, subtraction means division, so I'm going to rewrite it as the natural log of 3x squared over y. Why? Because that's the way you do the problem. It's kind of easier to condense than it is to expand. But that's it. That's how you do those 2 problems. If you're an individual that struggled with the left / checkpoint, this should get you through the previous checkpoint. And your last checkpoint is right here. Condense and evaluate those last 2. You can use a calculator for evaluate log base 8 of 57. Hint, hint, you should use change of base. Okay? That's it for checkpoints. That's it for the video. You should be good to go. Make sure you're comfortable with all the properties that I have listed here on this end slide because we'll be picking up from here in class tomorrow. Ooh, I forgot about today's password. Let's make today's password Go Kings because tonight is a season opener for the Sacramento Kings. So today's password is Go Kings. See ya.